In this video, we're gonna install Laravel and set up a project focused on building an API. No need for things like Blade or session management. We're keeping things simple and focused on endpoints and JSON responses. Let's go to our terminal, then create a new Laravel project. I'll name it Laravel _API, but feel free to use any name you prefer. Alright, I'll hit enter. Next, let's select the None option since we're building an API and won't be using any front-end scaffolding. Hit enter. Okay, for the database, you can choose whichever you prefer. In my case, I'll go with MySQL. Once we set the default database, Laravel will ask if we want to run the default migrations. I'll select yes, then hit enter. Laravel assumes that the database name matches the project name. Since I haven't created the database yet, I'm getting a warning message here. I'll choose yes again to let Laravel create the database. Once it's created, Laravel will automatically run the default migrations for us. Since we're building API, we don't need to run this npm install, so let's choose no. Okay, now let's navigate into our newly created project directory using cd Laravel API. Then I'll start the built-in Laravel development server with the command PHPUnit. Once the server is running, I'll open my browser and go to localhost /8000 to confirm that our Laravel project is running properly. And here it is. The Laravel landing page is displayed on the screen. So in this video, we created a new Laravel project and set up the database connection. In the next video, we'll move on to creating our first model, migration, and factory. In this video, we're gonna create our first model, migration, and factory for the application. A model in Laravel represents your business data and logic. It allows you to retrieve and store data from a specific database table in a clean and organized way. Now, when it comes to creating database tables, most people are familiar with using tools like PHPMyAdmin, Table Plus, or SQL Ace. And while those tools are handy, using migrations is a far better approach in Laravel. Migrations are like version control for your database. They track every change you make to the schema. And if you're working with a team, they help ensure everyone is using the exact same database structure, so your app behaves consistently across all environments. Next, to populate the database, you may be tempted to insert some fetch data manually using those same SQL tools. But Laravel gives us a more efficient way to do that with model factories. Alright, let's get into it. Let's open up our terminal and use php make model command. You can specify the model name directly, or if you're using Laravel 10 or newer, you can omit the name and Laravel will prompt you. Here, I'm prompted to enter the model name. I'll type in task and hit enter. Then, Laravel asks if we want to generate additional files like database seeder, factory, from requests, migration, policy, and resource controller. In this case, I'll select all options except for database seeder. Once that's done, Laravel generates the following files for us: the task model, a factory for generating fake data, a migration file for tasks table, 2 form request classes, a controller, and a policy. Now, let's open up the create tasks table migration file. Inside the app method, we'll define the structure of our table. We'll add 2 additional columns: name, which will be a string, and then is completed, which will be a boolean, with a default value of false. After that, let's move on to the factory. Let's open up the tasks factory. Inside the definition method, we'll assign some dummy values to our fields. For the name, we'll use fake sentence, and for is completed, we'll assign a random value of 1 or 0. Now, let's seed the database with some tasks. Let's open up the database seeder. Inside the run method, we'll remove any existing code and add the following: task, factory, 10, create. Don't forget to import the task model at the top here. Alright, let's give it a save. Back to our terminal. Then run the migration and see the database by saying php artisan migrate, and then add the seed option. Once it's done, let's open up our database and check the tasks table. And there we go. The table has been populated with 10 records of fake data, all generated automatically. Before we jump into building real API endpoints, it's essential to understand how APIs actually communicate. Think of this lesson as learning the basic vocabulary of how the internet talks. So, APIs work over a protocol called HTTP, and each request you send has a specific method that tells the server what kind of action you want to perform. You can think of these methods like verbs in a sentence. They describe what you want to do with the data. Let's go over the 4 most common ones you'll use in API development. The first method is get. This is used when you want to fetch data. For example, you want to retrieve a list of all posts or details of a specific post. This is like saying, hey, show me the data. So this method used for listing or viewing details. The second method is post. This is used to create new data. Usually, client fills out a form and sends it to the server. Server then creates and returns the new resource. For example, a user fills out a post form and submits it. It's like saying, here's new information, save it please. Next method is put and patch. Both are used to update existing data, but there's a small difference. The put method replaces the whole record, for example, edit title, body, and category of a post, while the patch method only updates the fields you send. For example, edit title of a post. It's like saying, update this record with the following changes. The last method is delete. As the name suggests, this removes data. You use this when you want to delete a record from the system. For example, remove a blog post. So it's like saying, please remove this item. Now, once you send a request to the API, the server always replies, not just with data, but with a status code. This code helps us understand what happened on the server side. Now, let's see the most common status codes you'll see often. 2xx for successful response, 4xx for telling client error, 5xx for telling server error, 200 or OK, meaning everything worked fine, the request was successful, and data is returned. 201 or created, used after a successful post request. It means we save your new data. 204 or no content, used after a successful delete. It means we deleted the data and there's nothing more to say. 400 or bad request, meaning the client sent something wrong, maybe missing required fields or sending invalid data. 401 or unauthorized, the request needs authentication. The user isn't logged in. 403 or forbidden, the user is logged in but not allowed to perform a certain action. 404 or not found, meaning the server cannot find the data you're looking for. 422 or unprocessable entity, meaning the request was well formed, syntactically correct, but the server couldn't process it because of semantic error. So the structure of the request is correct, for example, valid JSON or correct HTML method, but the data inside is invalid or false validation rules. 500 or internal server error, meaning something went wrong on the server, usually a bug or exception on your code. Now, these methods and codes might look simple, but they are critical. If your API doesn't follow these rules, front-end developers, mobile apps, or even third-party integrations will struggle to use it. When we follow the convention of HTML methods and return the correct status codes, we make our API predictable, easy to debug, and professional. Let's move on to the next video and learn about API versioning. Okay, before we dive into building the endpoint, let's take a moment to talk about something really important, API versioning. Now, if you're new to this concept, you might be wondering, why should I ever care about versioning my API? Here's the thing. Building an API isn't just about getting it to work today. It's about keeping it working tomorrow and the day after, even when your application starts growing and changing. Let me give you an analogy. Imagine your API is like a fridge in a house shared by multiple people. Maybe your mobile app uses it, your front end, maybe even a few third-party services. Everyone's going in and out of that fridge, expecting to find things where they left them. Now imagine one day you silently replace the milk with oat milk, the soda with tea, and you rearrange all the shelves. Suddenly, your roommate can't find anything. The breakfast routine is ruined and they're angry. That's what happens when you change your API, structure, behavior, or data without versioning. Your clients, meaning anything that consumes the API, they depends on things being consistent. If you break that, even if it's for a good reason like improving performance or fixing something, you might break their app, and that's not good. So what's the solution? Simple. Version your API. Instead of changing your existing endpoints, you introduce a new version, something like API v2 tasks, while keeping the old version API v1 tasks untouched. That way, old clients can continue to work as before, while new clients or updated apps can start using the improved version. So nothing breaks for users who still depend on it. This gives us freedom to improve, refactor, or even redesign our API without causing chaos for existing users. So yeah, API versioning isn't just about organization, it's about respecting your users and keeping things stable while you keep growing. So to summarize, here are the main reasons why API versioning is important. It prevents breaking changes for your existing users. It gives you freedom to improve and iterate on your API design. It provides clear communication. Users can instantly know which version they are using. It helps your API age gracefully, especially as your project scales or gets adopted by other teams. Alright, now that you know why versioning is important, let's move on to the next video and start building our first API endpoint. In this video, we're gonna create our first API endpoint. Let's start by navigating to app HTTP controllers folder. Inside this folder, let's create a new subfolder called API. And within it, another one named v1, short for version 1. We currently have a task controller located directly inside the controllers folder. Let's move that file into the newly created v1 folder. Next, let's open up the control file and update its namespace accordingly. Since the namespace has changed, we now need to import the base controller namespace, which is app HTTP controllers controller. Alright, now scroll down to the index method. Inside this method, we'll return all tasks from the database. Now, let's define a route for our API endpoint. Head over to the routes folder. Actually, since we're working with an API, we'll define the route inside the api.php file. However, starting from Laravel 11, the api.php file isn't included by default. If you're using Laravel 10 or below, you should already see the file there. To generate the file and other API related scaffolding, let's go to our terminal and run php artisan install :API. Hit enter. Laravel will install the Sanctum package and publish the necessary files, including the api.php route file. You'll also get a prompt saying a new database migration has been published, and it will ask if you want to run all pending migration. Let's type yes, then hit enter. Once completed, you'll see that it ran the migration for personal access token. Now let's open up the newly created api.php file. Actually, instead of defining just a single route for our index method, we'll define a resource route using Laravel's API Resource method. The path will be tasks, and we'll point it to our task controller. Don't forget to import the controls namespace at the top of the file. Also, since this is versioned, let's prefix the route with v1. You can add the prefix directly to the route, like this. But to keep things organized, especially if you add more routes later, it's better to wrap everything inside a rope group like this. Okay, let's give it a save. Back to our terminal, and then inspect our route. And there we go. Now we have a complete set of resourceful routes for our tasks endpoint. In this video, we're gonna learn about Eloquent API Resources. As the name suggests, Eloquent API Resources are especially useful when building APIs. They act as a transformation layer between your Eloquent models and the JSON responses returned to the client. In simple terms, they help us control how our model data is structured when sent as JSON. This gives us full flexibility to expose only the data we want and in the format we prefer. Alright, let's open up our terminal, and then to create an API resource, let's run php artisan make resource and then specify the resource name. In this case, tasks resource. Once created, let's open up the file inside app http resources. Now let's find the toArray method. Inside the method, we'll define which attributes from the task model should be exposed in the API resource. In this case, ID from this ID, and then name from this name, and is completed from this is completed. This ensures that each task returned in the API will only include these three fields: ID, name, and is completed. Now let's go back to the task controller. Here in the index method, instead of returning a raw Eloquent collection, we'll return a resource collection using task resource task resource, and then call collection, and then pass in our Eloquent collection. Don't forget to import the task resource, or start from Laravel 12. You can make it much cleaner by utilizing the toResource collection method like this. With this way, you don't need to import the resource namespace, because Laravel will attempt to locate a resource collection that matches the model's name and is suffixed with collection within the HTTP resources namespace closest to the model's namespace. Now, while we're here, let's also update the show method. In this method, since we're only returning a single task, we'll return a single resource like this. Or, if you prefer a static method version, you can also write task resource make, then pass in the Eloquent model. Both syntax are valid and will produce the same result. And again, start from Laravel 12. You can make it much simpler by calling the toResource method like this. Great! Now every time we return task data from our API, it will be neatly formatted using our resource definition. In the next video, we'll test both the index and show endpoints to see how the responses look. In this video, we'll learn how to write our first automated test using PHPUnit, the default testing framework that comes with Laravel. If you're completely new to testing, don't worry, I'll walk you through everything step by step. Now, before we start, here's something important to know. Laravel supports two main testing tools, PHPUnit and Pest. PHPUnit is the most widely adopted tool. Pest, on the other hand, is a newer testing framework that provides a more readable and expressive syntax. While Pest is great and many developers enjoy its clean syntax, in this course we'll stick with PHPUnit because it's more widely used in real-world projects and better supports by community at this time. If you're interested, Pest can be installed later in any Laravel project, but we'll focus on PHPUnit. So, why should we write tests? Writing tests helps us catch bugs early and ensure our API behaves the way we expect it to. It also builds confidence when we make changes or refactor code because our test will tell us if we broke something. In Laravel, writing API tests is surprisingly easy and powerful. Laravel gives us tools like getJSON for simulating HTTP requests, assertJSON structure to validate the response format, and refresh database to automatically reset the database before each test. Now, when writing a test, we typically follow a three-step pattern. First, arrange. We set up the data or environment we need. Act, perform an action like hitting an endpoint, and then assert. Make sure the results are what we expect. This is called the arrange, act, assert pattern, and you'll see it used in almost every test. Okay, first, let's open up the PHPUnit XML. This file is a configuration file for PHPUnit. In this file, make sure you enable these two lines. DB connection is SQLite and DB database is memory. Next, let's go to our terminal and create a new test file for our version API. Since our endpoint is API v1 tasks, we'll organize our tests accordingly. Let's run php artisan make test API v1 task test. This will generate a new test class at test feature API v1 test class.php. Organizing your tests by versioning like this helps keep things clean and scalable, especially if we add a v2 version later on. Let's open the file and write our first two tests, one for index endpoint and another one for the show endpoint. Before we dive into the code, here's an important rule in PHPUnit. Each test method must either start with the word test or use the test attribute. For this course, we'll stick with naming methods using test format because it's simple and works everywhere. Alright, we'll start by creating some fake tasks using Laravel's model factory. Then we'll call our endpoint using getJSON method. And then assert that the response matches what we expect. Alright, let's define another test. So we create a task and then for the act, make a get request to the endpoint with task ID. Then we assert the response contains the correct task data. Okay, let's break down what we just did. So we use task factory create to generate test data in the database, and then we call the endpoint using getJSON. Then we check that the response has status code 200. We use asset.json count to ensure there are exactly 2 tasks. And then we use assert.json structure to verify the shape of the response. And finally, we use assert.json to compare exact values. Actually, we need to call refresh database here. This way, we'll automatically reset the database before each test. Now, to run the test, let's go back to our terminal and run PHPUnit test. Laravel will automatically discover your tests and run them. You should see 2 passing tests with a green success message. Actually, we have 4 passing tests because Laravel include 2 tests for us. I'll remove the files. And then rerun the test. Now I see 2 passing tests. If there's a failure, PHPUnit will show exactly what went wrong, the expected versus actual output, which is super helpful for debugging. So if I go to task resource and then try to disable this column and then rerun the test, here I get 2 failing tests. Let me undo the change and then rerun the test. Okay, it's now green. Okay, that's it. You've just written your first automated test for your Laravel API. Now you can move on with confidence, knowing that your index and show endpoints behave as expected. In the next video, we'll use Postman to manually test these same endpoints and compare both approaches. Hi there, welcome back. In the last video, we wrote automated tests for our API using PHPUnit. Now, let's test those same endpoints manually using Postman, a popular tool for exploring and debugging APIs. Postman is great for quickly testing API requests, trying out different inputs, and inspecting the full response, like headers, status codes, and JSON data. It's also widely used by front-end developers who need to understand how the backend works and vice versa. So it's a good tool to get comfortable with. Before we open Postman, make sure your Laravel app is running with built-in dev server. I use her actually, so I can simply access my app by entering my project name, followed by a .test, But for this project, I will use the PHP billing server because I want to have the same top-level domain with my client app later on to prevent CORS issue. So here in our terminal, just run php artisan serve. By default, this will start the app at localhost :8000. You'll need this URL to test your endpoints. Okay, let's go to Postman and then create a new collection. I call it tasks. Inside the collection, let's hit the add request menu. Let's name the request. In my case, I call it retrieve tasks. In the method dropdown, let's select get method. In the URL fields, let's enter http localhost :8000 API version 1 tasks. Let's hit the send button. If everything works, you should see a JSON response like this. Each object in the data array represents a task in your database. Just in case you got an empty response, make sure your database has data. You can use Thinker or a seeder to create some tasks. Let's now test the show endpoint. Let's save this request, then duplicate the request, and rename it to retrieve a task. The HTTP method will be the same, while the URL we need to provide the task ID. For example, 1. Make sure the ID exists in your database. Now if we hit the send button, we should get a single task object inside a data property. Now when testing with Postman, always check the status code. It should be 200 OK. The structure of JSON response, and then the actual value returned. You might be wondering, why do we still need Postman if we already wrote automated tests? That's a good question. Postman is great for exploring and debugging. It's fast, flexible, and visual. But automated tests, like we wrote in PHPUnit, are better for long-term stability, especially in large projects and CI or CD pipelines. The best teams use both, and now you can too. You have now tested your first API endpoints using both automated tests and Postman. In the next video, we'll move on to handling POST requests and learn how to validate and store new data into the database. Hello again and welcome back. In this video, we're gonna learn how to accept data from the client, validate it, and store it in the database safely and properly. This is the first step in making our API interactive, so users can actually create tasks via a POST request. Before saving any data to the database, it's important to validate it. Why? Because we don't want empty fields, invalid values, or broken data in our app. Laravel gives us a clean way to handle this using form request classes. We've already created a class called storeTaskRequest. This class will handle validation logic before the controller even tries to store anything. So let's go to the authorize method. Here, let's return true, since we don't want to perform any authorization. Then, let's go to the rules method. And then define a validation rules for the name field, like so. So here, we're telling Laravel that the name field is required, it must be a string, and cannot be longer than 255 characters. Laravel will automatically return a 422 unparsable entity response if this validation fails, with clear error messages in the response body. That means we don't even have to manually write validation logic in the controller. Now let's open up the task controller. Since we're building an API, we don't need to define the create method, so let's get rid of that. Then, here in the store method, let's call the task model, then save the incoming requests by calling the create method, and then pass in the validated request data. Now, since the create method will return a model instance, we can assign it to a variable. After that, we can return the newly created tasks as a JSON response. Let's break this down. First, we accept the validated request using store task request. Then, we call request validated to get the saved filtered input. We create a new task using task create. Finally, we return the new task using the toResource method for consistent API formatting. For this to work, don't forget to define the name field in the fillable attribute in our task model. So let's open the task model. Define the fillable attribute, and then specify the name field. Awesome! You've now built a secure POS endpoint that validates user input and stores it into the database using form request and Eloquent. In an upcoming video, we'll test this endpoint using both automated tests and Postman, so stay tuned for that. But before that, in the next videos, we'll learn how to update an existing resource using put or patch method and handle validation in a similar way. See you there! In this video, we're gonna implement two types of updates for our tasks. First, updating the task name. Second, marking a task as complete or incomplete. Along the way, we'll also reuse validation logic and follow clean control conventions. Okay, let's start with updating the task name using a put request. To do this properly, we'll validate the name field in the update task request. Now here's a cool trick. The validation rules for updating a task are exactly the same as when we create one. So instead of copying and pasting the rules again, we can simply extend our store task request. Now we don't need these authorized and rules methods because they are inherited. And we can also remove the form request namespace from here. This is a clean and dry or don't repeat yourself solution. If we ever update the rules, we only need to do it in one place. Next, let's go to the task controller. Here we don't need the edit method for our API, so let's get rid of that Then in the update method, let's update the task by calling the task instance, then call the update method, and then pass in the incoming request that has been validated. Once updated, we'll return it as a JSON response. So let's break this down. Laravel automatically injects the task model based on the ID in the route. Laravel injects the validated data from our request. We update the task using Eloquent's update method. Then we return the updated task using toResource method for consistent response formatting. And again, make sure that the name field is listed in available attribute in the task model, or this won't work. Now, let's say we want to toggle the completion status of a task, mark it as completed or not. This is a very specific action, and it doesn't quite fit the typical RESTful actions like update or store. So instead of stuffing it inside the task controller, we'll create a dedicated controller just for this action. Let's open up our terminal and generate a new controller. I call it complete task controller and add an I option or invocable option. An invocable controller only has one method, invoke, which is perfect for a single action endpoint. Let's open up the control file. Actually, let's move this file into API v1 folder. Open the file, adjust the namespace, and then import the controller namespace. In the invoke method, we'll update this completed field. Actually, let's type in the task model in the second argument. Here, let's update the isCompleted field with a value that comes from the request. Then, to persist the change, let's call the save method. Once it is updated, we'll return the task resource by calling the toResource method. Next, let's validate the incoming request just to make sure that the isCompleted is not empty and only contains a Boolean value. So I'll replace this with complete task request. Now let's define the validation logic there. Let's go to our terminal and generate a request called complete task request. Let's open the file, change the authorized method to return a true value. Then, inside the rules method, let's define validation rules for isCompleted fields like so. This ensures we only accept a true or false value for is completed. Okay, back to our controller, and then import the complete task request namespace. Don't worry if your editor cannot detect the is completed. I think it should be fine. Last, let's register a new route in api.php. Let's open up the file. And then define a new route for our newly created controller. It's gonna be patch. The route path is gonna be tasks. It receives an argument, task. Then we'll be suffixing it with complete. And the controller will be complete task controller. This route uses the patch method because we're only partially updating the task, not replacing the whole thing. Now, you might be wondering, why not just put this logic in the update method of the task controller? It's a good question, and the answer is about separation of concerns and following RESTful conventions. A resource controller, like task controller, is meant to handle the main CRUD actions, create, read, update, and delete. But when we have a very specific and isolated action, like completing a task, it's often better to create a separate controller for clarity and maintainability. Okay, great! You've now learned how to reuse validation logic across requests, update a resource using put and patch methods, and then add a custom action using an invocable controller. In the next video, we'll add another endpoint to remove an existing resource using the delete method. See you in the next one. Hello and welcome back. In this video, we're gonna implement the delete functionality in our Laravel API. This will allow users to remove a task permanently from the database. In a RESTful API, deleting a resource is typically done with the delete HTTP method. In Laravel, we'll handle this using the destroy method inside our task controller. So let's open up the task controller, then go to the destroy method. Inside the method, we call the task instance, followed by the delete method to delete the task from the database. After that, we'll return a content response. Here's what's happening. So, we call task delete to remove it from the database. If we want to hide tasks, instead of deleting them permanently, Laravel supports subdeletes, but in this course, we'll use hard deletes to keep things simple. Then, we return a 204 no content response using response no content. In REST APIs, when you successfully delete a resource, it's common to return HTTP status 204, which means the request was successful, but there's nobody in the response. This keeps the response clean and efficient. In the next video, we'll test our endpoints using automated tests, just like we did for the index and show routes. See you in the next one. In this video, we'll continue improving our API by running automated tests for remaining endpoints, such as create a new task, update existing task, mark the task as completed or incompleted, and delete a task. Previously, we already wrote automated tests for get task to fetch all tasks, and then get task ID to fetch a single task. If you missed that part, be sure to check out the previous videos. First, let's test if we can successfully create a task. We'll send a post request with a valid name field. Then we check if we receive a 201 credit response. And then we check if the return JSON structure is correct. And then we check if the task is actually saved in the database. Okay, let's give it a save. Go to our terminal and run PHPUnit test. Okay, our test is passed. Next, let's test validation when trying to create a task without a name. Here, let's send name with empty value. According to our rules, this should fail and return a 422 status with validation errors. To check the validation error, we can use assert JSON validation errors and then specify an array and specify the key, in this case name. Let's go back to our terminal and then rerun the test. Get error. Okay, it should be assert JSON validation errors. Rerun the test. Okay, we get green. Let me open the store task request and then disable this rule. I should get a failing test. If I now rerun the test, here I got 2 errors. This is because we expect to get 422 error, but since we disable this, we get another error. Now let's test the update endpoint using put method. First, let's create a task using factory. Then let's update its name by hitting the update endpoint. Here, let's specify a new name. After that, we assert that the response shows the updated name. Okay, let's test. Okay, we get green. Now, let's test what happens when we try to update a task with an empty name. Let's create a task and then update the task and then specify an invalid name. Just like the create route, This should return a 422 response with validation errors. Let's run our test. Okay, we got green. Let's now test our custom endpoint for marking a task as completed. First, let's create a task with factory, and we set the is completed with false. After that, we'll hit the complete task endpoint. Here we pass is completed with true. If successful, this completed should be true. Let's run the test. Okay, it's green. Now, what if someone sends a string like yes instead of a boolean? Let's make sure that's caught by our validation. Let's change the value to a string. We expect a status 422, and then we expect to get a validation error. Let's run the test. Okay, we got green. Okay, finally, let's test deleting a task. Hit the delete task endpoint, and we expect a 104 no content response, and for the task is no longer exists in the database. We can do that by using assert database missing, specify the table name, tasks, and specify the columns or fields, in this case ID. Okay, let's give it a save and run our last test. Okay, we got green and our tests all successful. Okay, now your API is not only functional but also fully tested using PHPUnit. In the next video, we'll switch to manual testing using Postman to see how each endpoint behaves in real time. I'll see you there. Hi, and welcome back. In this video, we're gonna test the remaining endpoints in our API, this time using Postman. So far, we've already tested our get endpoints. Now let's manually test the create new task endpoint, update existing tasks, mark tasks as completed or incomplete, and delete existing task endpoint. Before we begin, make sure your Laravel server is running. Now, let's go to Postman and let's get started. Let's start by testing the post request to create a task. Let's duplicate an existing request. I'll name it store a task. Select post method. Set the URL to API v1 tasks. Next, let's go to the body tab. Choose raw option and select JSON option. In the body, let's add this payload, name and then specify the task name. Then let's go to the headers tab and then make sure you have accept application JSON and then content type application JSON. Now let's hit the send button. You should receive 201 created response with the task data inside the data property. If you send an empty name, you get 422 unprocessable content error as you expect. Next, let's update the existing task. Let's save this request and then duplicate this one. I'll rename to update task. Let's change the method to put and then change the URL by providing the task ID, in my case 1. Now let's go to body and then specify a new task. When you hit the send button, you should see a 200 OK response and the updated task. Try removing the name or making it empty. You'll get a 422 unprocessable content error. Of course, with validation message. Alright, now let's mark the task as completed using a patch request. Let's duplicate this request and then rename to mark maybe complete task. Let's set the method to patch and then adjust the URL. Next, let's go to the body tab and then provide is completed with true. Let's hit the send button. As you can see, it's completed now true. If I change to false, now it's completed is false. If I send a string like yes, instead of true or false, you'll get a 422 unprocessable content error, which is exactly what we want. Finally, let's test deleting a task. Let's duplicate this request, rename it to delete a task, change the method to delete, and adjust the URL. When you send a request, you should get a 204 no content response. That means the task was successfully deleted. If you try to hit the request again, you should get a 404 not found error because the task no longer exists. So in this video, we've tested all our major write or modify actions such as creating tasks, updating existing tasks, marking tasks complete, and deleting tasks. We also saw how Laravel handles errors, status codes, and responses in a very developer-friendly way. And that's it for manual testing with Postman. You've now tested all the key actions in your API, from creating and updating tasks to marking them complete and deleting them. In the next video, we'll wrap up everything we've built so far and reflect on what you've learned in this section. See you there. Hi there, and welcome to a brand new chapter of this course. Up to this point, we've built a fully functional API using Laravel, but so far our API is wide open. Anyone can fetch, create, update, or delete data without logging in. In the real world, that's not secure. That's why in this section, we're gonna explore authentication and specifically how to secure our API using Laravel Sanctum. So what is Sanctum? Laravel Sanctum is a first-party package from the Laravel team that provides a simple and lightweight authentication system for APIs and HPAs or single-page applications. It's built on top of Laravel's authentication features, but with APIs and JavaScript front-end in mind. It's easy to set up, doesn't require all-out, and supports both session-based and token-based authentication, making it perfect for most modern applications. Why do developers use Sanctum instead of Passport or GWT? First, it's much simpler. You don't need to deal with complex auth flows or install heavy packages. Second, it supports two types of authentication out of the box. API token authentication, which is great for mobile apps or third-party API clients, and SPA authentication, which is ideal for single-page apps built with Vue or React using cookies and CSRF protection. Here's the big picture of how Sanctum can be used. First, API token authentication. This approach is useful when you want a client, like a mobile app, Postman, or an external service, to log in once, receive an API token, and then send that token in every request header to access protected endpoints. With this setup, you can manually issue API tokens for a user, limit scopes or abilities per token, which is optional, authenticate each request by verifying the token. The second approach is SPA authentication, and it works differently. In this method, Sanctum works alongside Laravel's built-in session-based auth system. You log in from your JavaScript frontend using a POST request. Laravel issues a session via cookies. Then your front-end app can make authenticated API calls without managing tokens manually. Then, your front-end app can make authenticated API calls without managing tokens manually. This is perfect for SPAs using Vue, React, Next.js, or Nuxt, where the front-end and back-end share the same domain or are configured for cross-domain requests. In this course, we'll learn both methods, starting with API token authentication, then moving on to SPA authentication. We'll secure our routes, allows user to register and log in, and make sure tasks are tied to the currently authenticated user. We'll also explore middleware protection, guarding routes, and how to work with Sanctum in a clean and maintainable way. So now you know what Sanctum is, why it's useful, and how we'll use it in our Laravel API project. In the next video, we'll begin installing Sanctum and setting it up step by step. Let's make our API secure. See you there. Welcome back. In this video, we'll install and configure Laravel Sanctum specifically for API token authentication. The good news is, if you're using Laravel 11 or newer, the process is extremely simple. If you're using Laravel 11 or newer, Sanctum is already included in the framework. All you need to do is run one command: php install API. This command does a few things: publishes the Sanctum config file, runs the necessary migration file, and ensures Sanctum is ready for token-based authentication. If you have already run this in the previous section, you're good to go. You don't need to run it again. If you're using Laravel 10 or below, the setup process is a bit more manual. You'll need to install Sanctum using Composer, publish the config file manually, and register Sanctum's middleware yourself. I won't go into those steps here, but if you need to, you can check the official Laravel documentation for relevant version. Now, let's talk about how Sanctum handles API token authentication. Laravel uses the has API token trait on the user model to manage tokens. So open your user model and then use the has API token trait. This trait allows each user to issue one or more personal access tokens. Once Sanctum is set up, your app can authenticate a user using email and password. After successful login, you can generate a token using the createToken method from the user instance. That token can be returned to the client. The client will include it in the authorization header on every request. Sanctum will validate the token and authenticate the user behind the scenes. For API token authentication, you don't need to add any special middleware to your API routes group. Laravel Sanctum handles token parsing automatically for routes that use the default API middleware group. So, if you define your route like this, it will only be accessible if the request includes a valid token. Let's quickly recap what we did. We ran PHPUnit install API to configure Sanctum, if not already done. We confirmed the has API token trait on our user model. We understood how token generation and validation works. And then we saw how the Sanctum middleware protects our routes. In the next video, we'll create a login endpoint that authenticates the user and returns an API token. That's how we'll enable clients like Postman or mobile apps to interact with protected routes. See you in the next one. In this video, we're gonna create a login endpoint for our API using Laravel Sanctum. This endpoint will allow users to log in with their email and password, and in return receive an API token that they can use to access protected routes. In the real world, not everyone should be able to access your API. We need a way to verify a user's identity and issue them a secure token that proves they are logged in. That's exactly what we'll build in this video. But before we begin implementing authentication, there's one design decision I want to explain. You may notice that while our API resources like tasks are versioned under API v1 tasks, our authentication endpoints such as login and register are not placed under v1. This is intentional. In this course, we're designing the API to support two types of clients: one that uses version 1 API v1 tasks without authentication, and one that will later use version 2 API v2 tasks, for example, with full authentication support. So if we placed login under v1, it would feel inconsistent because the client would authenticate via v1 login, but then access version 2 of the resources. That would confuse the structure. By keeping authentication endpoints outside of versioning, we treat them as global entry points to the system. This approach is also common in many real-world APIs. Later on, if we need to version authentication behavior, like adding 2FA or changing the login flow, we can still introduce v2 login when needed. But for now, this simpler structure makes learning and implementing much easier, especially for those just getting started with API authentication. Alright, with that in mind, let's get started. First, let's create a form request to validate the login credentials. Let's go to our terminal, then create our login request. This gives us a clean place to define our validation logic. Inside the login request class, let's go to authorize and then change this to return true. Then inside the roles method, let's add email. It should be required and a valid email. And for password, it also required. So this ensures the client sends a valid email and an empty password before they try to authenticate the user. Now let's create a new controller to handle authentication. Let's go back to our terminal and then run php make controller. We'll place it inside API auth and then login controller, and then we'll add I flag to make it invocable controller. Okay, let's open up the controller. Then let's call the login request here. Next, let's go to the method body. Then let's find a user by the given email and assign it to a variable. Next, we'll check if the given password matches the password in the database. To do that, we'll use a check method in a hash facade. If it fails, meaning user is not found or the given password doesn't match, we'll throw a validation exception with a given message. But if it succeeds, we create a personal access token by utilizing the createToken method. Specify a token name, then get the actual token by accessing the plain text token property. Then we return the token as well as the authenticated user in a JSON response. Let's also specify the HTTP response code. In this case, HTTP OK. Now we need to define the login route in our routes API. Let's prefix our authentication endpoints with auth. It's gonna be route post, login, and then login controller, like so. That's it. Our login endpoint is now available at API auth login. Now let's write automated tests to make sure our login endpoint works as expected. Back to our terminal, then run php artisan make test API auth test. Inside the auth test, let's define a new method. Let's provide a fake user for our test. This will generate user with random name, but for the password, it will be the same, which is password. Once user created, we'll test hitting our login endpoint. And provide a correct credential. Then we'll check the response status code. Let's also make sure we get a proper JSON structure. Okay, let's duplicate the test. Then adjust the method name. Here we hit the login point, but will provide incorrect credential. As you may guess, the expectation for this response is assert status 422. Also, we expect to get validation errors with email as the key. So this test makes sure login works when credentials are valid, and then login fails gracefully with incorrect input. Now let's run the test. Back to our terminal, and then run php artisan test. Now to run only the auth test, we can use filter option and specify the class name or method name to be executed. In this case, auth test. Okay, we need to use here refresh database straight. Okay, one failed, one pass. I'm sorry, I made a typo here. It should be password save, rerun the test. Okay, now we get green, meaning our tests are successful and the login feature is working as expected. Let's now test our login endpoint manually using Postman. Let's go to Postman. Let's create a new collection. In my case, I'll call it token authentication. Inside that, let's add a request. I'll call it login. Let's set the method to post. The URL will be http localhost API auth login. Let's go to body and then select raw option, set type to JSON. In the JSON body, actually I need to generate a user in my database. So let me go to my terminal, go to Tinker, and then generate a user. Let me copy the email, paste it here, and then specify the password. Next, let's go to headers tab and then add accept application JSON and then content type, also application JSON. Let's hit the send button. Actually, the method should be post. If login is successful, you should see a 200 OK response and response body like this. But if the credentials are incorrect, you'll get a 422 status code with error messages like this. Now the user has a token they can use in future requests. Once the client has the token, they can send it in the future request using the authorization header. Sanctum will automatically validate the token and grant access to protected routes. And that's it. You've now created a secure login endpoint using Laravel Sanctum. You've validated inputs, returned a usable token, and wrote tests to ensure everything works correctly. In the next video, we'll build the register endpoint. See you there. Welcome back. In this video, we're gonna build a user registration endpoint for our API. This endpoint will allow users to create a new user and immediately receive an API token they can use to access protected routes. First, let's create a form request to validate the input. Let's call it register request. Inside the authorized method, we'll return true. Then inside the rules method, let's add these rules: name, required, string, and then max 255. For email, it should be required email or valid email and unique users email. So this makes sure only one unique email in the users table. For the password, it should be required minimum 8 characters and then confirmed. So the confirmed rule ensures that password underscore confirmation is present and matches the password field. Back to our terminal and then generate a new controller. Let's call it, actually we'll put it in API of, and then we call it a register controller and then make it as invocable controller. Let's open up the file. Let's change the request to register request. Inside the method body, we'll create a new user and assign it to a variable user. Next, let's generate an API token. And then return a JSON response. Which contain token and then user. For status code, it will be response HTTP created. So this method validates the input and then creates a new user securely with encrypted password, generates an API token, and then returns both token and user information. Let's now add the route in our routes API. Inside the auth group, let's add route post register, and then we call register controller. Let's now write a test to confirm that registration works properly. Let's open up auth test inside tests feature API auth. Then let's add a new test. First, let's define a request payload. Next, let's hit the register endpoint using post.json and provide the payload. Now let's check the response. We expect to get HTTP status code 201. We use assert created. We also expect to get JSON response which contain token and user. Let's also make sure the user exists in users table. Okay, let's duplicate the test. Then adjust the name. Let's provide invalid payload. So the expected status code is 422. And we expect to get validation errors for name, email, and password. So these tests ensure both the success path and failure path are working as expected. Let's run our tests and hopefully we get green, meaning our last tests are successful. We got one test failed. So the last test is failed here. User cannot register with invalid data. Let's try to change this to wrong email. Let's run the test again. Okay, our tests are passed, meaning the register endpoint works as expected. Let's now test the register endpoint using Postman. Let me save this request and then duplicate it. Let me rename to register. The method should be the same, post, and the URL will be API auth register. The header will be the same, and for the body, let's provide email. Let's say johntest.com, password, and then password confirmation. Also name. If successful, you'll get a 201 created response with this response body. But if we provide an invalid payload, we'll get 422 status code with validation error messages. Now that users can register and receive an API token, they can use it to interact with authenticated routes. In the next video, we'll build the logout endpoint so users can safely revoke their tokens when they sign out. Great! You've now completed a secure and tested user registration flow in Laravel using Sanctum. See you in the next video where we complete the authentication loop with logout and token revocation. In the previous videos, we'll learn how to log in a user using Sanctum and how to return a secure API token. Now it's time to close the loop by allowing users to log out, or more accurately, revoke their token. Since we use Sanctum for API token-based authentication, when a user logs in, a personal access token is created and stored in the personal access tokens table. Logging out means deleting the token from the database so it cannot be used anymore. Okay, let's open up our terminal and then create a new controller. I'll call it logout controller and place inside API auth and then make it as invocable controller. Then inside the logout controller, we'll call request user and then current access token and then call the delete method. After that, we return response no content. What this does, it retrieves the token used in the current request, then deletes that token from the database. Last, we return no content response. Since we access the authenticated user instance, that means we need to define our route in auth Sanctum middleware. Now let's open the API and then define the logout route inside our auth group. Let's call middleware auth Sanctum. So again, only logged in users can access this endpoint. Let's now write a quick test to verify the logout flow. Let's open auth test, then add a new function or a new test. Let's create a user Once created, we'll create a token to simulate a successful login. Then, let's hit the logout endpoint. And we don't need to pass any payload. Note that the endpoint uses auth Sanctum middleware, so before that, let's call the with header method. Specify the header key, authorization, and the value will be better, add a space, and then pass a token. Once we hit the endpoint, we expect to have 204 status code. Now, to verify if the token is no longer valid, let's hit the protected endpoint like so. Note that this user endpoint is protected route, and we should get a 401 unauthorized status code. So this test simulates a user with a valid token and then logging out and then trying to access protected routes after logout. Let's give it a save and run the test. Our test is failed. Expected response status code 401 but receives 200. Let me add this line. This app off. Forget guards. So this way, we'll flush guards to reset auth state and simulate a fresh request. Let's run the test. Okay, it's now green. So our test is successful and the logout endpoint works as expected. Let's now try logging out using Postman. Let's duplicate this request and rename it to logout. The method will be post. This will be API auth logout. The header will be the same, but we also need to add authorization here to bearer token. And then for the token, let's grab it from here. Paste it there. Okay, we don't need the body here. Now let's hit the send button. Okay, if the token is valid, you should get 204 in the content. After that, if you try to access any protected route using the same token, it should return 401 authorized. So let me add here HTTP localhost API users. Let me check that. User. The method will be get and then try to hit the endpoint. Oops. Header should be accept application JSON, then content type, also application JSON. Hit again. Okay, here we get a 401 unauthorized status code. Great! You've now completed the full API token authentication cycle, such as login, register, use tokens to access protected routes, and log out securely by revoking the token. In the next video, we'll see how to use Sanctum for SPI authentication. See you there! In this video, we're gonna test protected routes in our Laravel application using both PHPUnit and Postman. The goal is simple. We want to make sure that authenticated users are denied access, while authenticated user can access protected resource successfully. Open your test file, in this case auth-test.php. Now let's write our first test method. This one will check that guests or users who are not logged in cannot access the API user endpoint. This test makes a JSON GET request to API user and expects a 401 unauthorized response, which is the correct behavior when no user is authenticated. Now, let's run this test in our terminal. PHP artisan test filter and specify the method name. If everything is working correctly, you should see that the test passes. Next, let's write a second test to ensure that authenticated users can access this route. First, let's create a fake user. Then, to simulate login using Sanctum, we can call this acting as, then pass in the user. Then, we make a GET request to the API user endpoint, which is a protected route. This time, we expect a 200 OK status. And a JSON response that includes the user ID and email. Now let's run this test. And again, if everything is working, this test should also pass. Now let's see how to test a protected API route in Laravel using Postman. First, let's open Postman. I've already created a request to access API user endpoint. So if we try sending this request by clicking the send button, as expected, we get a 401 unauthorized error. This tells us that the request is being blocked because there is no valid authentication token included. That's normal behavior for protected routes. Now let's log in to get an access token. Great, the login is successful, and we get back a JSON response that includes the access token and user details. Let's copy the token from this response. Go back to the previous request. Open the authorization tab. For the auth type, let's choose bearer token. Then paste the token into the token field. Let's hit the send button again. This time it works. We get a 200 OK response, and the response body shows the details of the currently authenticated user. This confirms that our token-based authentication is working correctly and that the API user route is protected as expected. So that's how you test protected routes in Laravel using Postman and token-based authentication. This method is especially useful for testing APIs outside of the browser, like mobile apps or third-party services. Okay, that's it for testing protected routes in Laravel with PHPUnit and Postman. See you in the next section.